So I just wanted to go over this last question. So a HPLC, high performance liquid chromatography, was used to determine the concentration of ethanol in a sample of wine. Okay, so chromatograms were obtained from 4 standard solutions of ethanol, and the ethanol peak areas from each solution was calculated. The peak area was then determined from the chromatogram of the wine sample. Use the data to draw a calibration graph and hence determine the ethanol concentration of the wine. Cool. All right, so we're looking at a concentration kind of question here, which gives us an indication this is a quantitative type of question. So we're looking at the quantity of ethanol in the wine. We already know it's ethanol, so we've already run a qualitative analysis on it. We know we're interested in ethanol. Okay, so we have some data here, and we've got 4 standard solutions which they have popped into the machine. So what that means is that they would have got 4 separate chromatograms for each of these samples. 1, 2, 3, 4, and they would have been pure ethanol of different concentrations. And when they ran each of those through the machine, they would have got a chromatogram with a different peak height. Okay, or peak area rather. So different peak area. Often the graphs are calibrated so the height is an indication of the area anyway. Okay, so we've gotten a different peak area for each of these standard solutions. Okay, so how does that help us? Well, what we can do then is pop our sample of wine through the chromatogram, and we might get other peaks because there might be other stuff in the wine. But we know that, say this peak would be ethanol because we have determined the retention time of ethanol previously. So each of these may have occurred at, say, 2 minutes. Okay, 2 minutes, 2 minutes. That's the qualitative type of analysis on it. So we know this peak is ethanol because it occurs at 2 minutes. Okay, so retention time is handy to give you an indication of what it is, qualitative. Okay, what it is. So we know this peak is ethanol because it occurs at 2 minutes. That's the retention time of ethanol. Okay, I've just made that value up. Anyway, so we've got our peak areas for each of these. Yep. Awesome. We know the concentration of that is this. Okay, of 2 is that, of 3 is that, 4 is that. And we've got those different peak areas from our chromatograms. So then we pop in our sample of wine and we get these peaks, and we know that's ethanol because of the retention time. And so the peak area here is given by this value here, the machine tells us, okay, often indicated by the y-axis. So we have a peak area value. All right, awesome. So what can we do with our standard solutions? So standard solutions can be made into a calibration graph. Okay, so from here, what we can do is we've got peak area versus concentration. We've just drawn up a simple linear graph. So from here, what we can do is find our 3.6 times 10 to the 6. So everything's 10 to the 6 here. So 3.6, we draw across. We go down and we estimate the concentration of ethanol in this wine to be, well, I'm not sure what your booklet says, but say that's like around 11, what would it be? Maybe 11.5 or something like that. So 11.5 times, oh no, that's it. So percent volume by volume. So that just means that there's 11.5 mils per 100 mils of wine in my sample. Okay, so hopefully that helped a little bit.